Okay, hey everyone. I just want to shout out a special thanks to all of our clients, partners, and a few prospects for being here. You're making an investment and a commitment to the company, which we really appreciate. So I'm very excited to talk about our telecom solutions. So this is going to be kind of two-pronged. It's product focused, but it's also going to be looking at the industry and what we're doing to support what we think is a really key value proposition here. So if we look at, let's see here, the kind of key topics that I'll cover today. So we'll talk about the Automated Broadband Designer 9.1 release, some of the specific things about that, new telecom users, so new clients. So we want to give a shout out today to some of our most recent clients. We've joined an organization called the Fiber Broadband Association, and I'll tell you a lot more about that in a moment. And then I wanted to kind of just touch on key use cases and customer value, right? So as Al said in the beginning this morning, it's all about you guys being successful, and if we can help you be successful, we've really done a good job, in our opinion. So that's the idea there. So ABD, or Automated Broadband Designer 9.1. An interesting story that Sangeetha from Aecon may mention during her presentation coming up later today is that we kind of polled some of our friends and partners and internally on what we ought to brand, this new product. And there were two key messages that came through. One was, well, you've got to honor the AUD brand, right? Like it's an established product, it's in use at, hundreds of utilities. It's a proven platform and product, with really solid benefits. So we want to honor that. The other piece was this notion of, is it communications, is it telecom? And it was one of Sangeetha's colleagues, Roger, who said, well, telecom's kind of an old term. It's broadband now. And so I thought, well, that actually sounds pretty accurate, right? So we decided to go with the broadband term. And that, to me, is not confusing, right, when we're talking about broadband technology and networks. So we think that's a great fit. We've created a new base design, or a base configuration for design. And that means that there's a lot of very specific configuration in the product, but we've also made some enhancements. And those enhancements are to support things like micro-duct hierarchies. And just for context, if you think about some of these residential fiber networks, these fiber to the home networks, they deployed these things, through a direct bore, construction technology. They're called micro-ducts. And this is an assembly, sometimes like a 15-way micro-duct. And these things are tiny, like they're, quarter-inch in diameter. But they put them in empty. And then they get coupled together so that now you've got predefined routes that go all through the network and eventually show up at someone's home. And you can actually push fiber through those, using a technology called blown fiber. So it's a really interesting technology, but in order to get the construction right, you've got to have a very precise hierarchy of how these things are put together, how they connect, how they're routed through the network. And construction teams and installation teams, need to have a lot of detail about that. So we really focused on that piece. Another one was stationing. So we saw time and time again these construction packages showing up with traditional, CAD-style stationing. And we thought we need to integrate this into the telecom design. So we've done that. And then there's a lot of detailed equipment that's out there in vaults and manholes and handholds and things called flower pots, these kind of mini handholds. And there's a lot of equipment out there in telecom that gets installed. So we had to adapt the system for some of these new and complex hierarchies. And this notion of contained, equipment in these structures. So we've done some work with that. And then the final piece is we're introducing a new thing called fiber line account, which I'll describe to you in a bit of detail here in a moment. But I wanted to talk about micro-ducts a little bit as well. So you can kind of see an example on the screen there. So you've got this bundle, this micro-duct bundle, and they get color-coded, they get numbered, and you need to keep track of which cables are in which micro-ducts. And so we've created simple user interfaces. For example, I know that there's a cable coming into this handhole, for example. I can, right-click on a duct and it shows me the available cables, and I can say I want to drop that cable in. It's kind of like what Dave showed earlier when he was talking about, selecting these conduits or ducts for cable placement. And it actually turns out to be a super convenient way for users to interact with the system. And then the other piece is kind of seeing the current status, right? So you've got 15-way coming in on one side, you've got multiple, 5-way or 7-ways coming out the other side. What's connected to what? And you can see there's an example of these micro-duct tie-ins and couplers. And so it's quite a bit of detail, but it's essential for these deployments that they handle this. Another piece, I mentioned containment hierarchies. So splice enclosure, right? So you open up this handhole, you're looking at a picture of one there. You can see there's this splice case inside of it. There's multiple cables coming in. There's ducts and conduits, coming in. And that all has to be managed. So we've done quite a bit of work on managing the hierarchy and how that's presented to the user, and also how that can be created efficiently, through automation. And so we've added automation around these hierarchies and how things connect. So you can kind of see, a detailed model on the right-hand side there. But another example, in going in a little bit further here, let's see, is this splice closure detail, or splice enclosure. And if you look at these things, they look simple from the outside. So it's a basic, kind of sealed, environmentally safe, environmentally resistant structure. These can be mounted up on an aerial strand. They can be in a handhole. They can be in a manhole, vault, etc. But there's a lot going on here. So there's cables coming in and out of this thing. The cables then go into ducts and conduits, and then they get spliced together. So there's connectivity that's happening too. So again, you can see this kind of telecom domain model. We take a real-world example, and then we make sure that the ABD system can reflect what's really being deployed out there. So these are just some examples I wanted to share with you. Fiber line of count. And so when you think about fiber connectivity, it can be quite complex, but in essence, when these networks are designed, there's kind of a flow to the network. And if you're starting in a central office or a hub site or a large cabinet in the field, you'll have this notion of a patch panel, and the fibers will terminate there, and then the fibers go on their way and they get spliced and they get split, and eventually they end up at a business or a home. And the way to track those is using this methodology called line of count, which is basically a logical grouping. So it's kind of a designation, like it starts at cabinet A. And then what happens? Well, cabinet A has 864 fibers. So it's A1 to 864. So now we know, okay, those all originate in one place. Till eventually you might get 2 fibers that end up at a home. And that might be like A fibers 801 and 802. And it's a nice, simple way to track that. But you don't want to maintain it manually. So we've added a lot of automation and validation for managing this. And I think it's going to provide, again, high productivity for managing fiber connectivity through the design process. So we're very happy about that. So new telecom users. So I mentioned Sangeetha from Aecon is here. So Aecon is headquartered in Toronto, and she'll tell you all about the company. Wonderful quote here from Aecon. But basically, they are a large engineering firm, and they wanted to start with a project for one of their key clients. And the idea was to kind of tackle a very large, complex fiber-to-the-home standard and treat that as their new baseline. And all other projects in the telecom sector will kind of flow from there. And so again, we dug in deep with the team. They've been absolutely fantastic. There's been 5 or 6 people from their team, all in the design and engineering team. They've been with us from day one. I have to shout out to Jim Lucas and Sarah Jones. They've been instrumental in making this project a success. They are in system testing, but again, I'm going to let Sangeetha talk to you all about that at 1 o'clock. C-Spire is another new customer of ours. And they are what I would call like a mid-tier communication service provider. So they provide wireless services, traditional telecom services, and fiber. And they're in Alabama and Mississippi. They serve about, they're a little over 1 million customers at this stage. And again, the quote that I really, jumped out for me is when they saw our system and they started kind of discussing with their teams how they would use it, they said this is the first major quantum leap in ensuring all our design standards are met. So that's a really fantastic quote. We're happy about that. We're also working with 2 of their contractors, UDP and BBG, so Utility Design Partners and BB Geomatics. And they are long-term partners with C-Spire, and they've really jumped on to the ABD bandwagon. So they have started using the system. They're now in the process of doing what's called a middle mile fiber design, which is an NTIA standard. So we're really excited about getting going with all these guys. The next thing is the Fiber Broadband Association. So when I joined the company, I had spoken with Al and I said, if we're going to affiliate ourselves with an industry organization, it has to be these guys. So last year we attended, and Al and I were there with one of our board advisors, Marty, and it was clear that this was the place to be if we wanted to become a key player in the broadband space. And so we joined. We exhibited earlier this year, and it was a tremendous success. We were the only company there really showing automated low-level design, permitting and construction drawings. There were lots of vendors there showing GIS capabilities of different types, but we were the only company that I could see on the whole show floor that was really focused on the problem of adding productivity to low-level design, like detailed design, and then creating applications for permits, jurisdictional, requirements, and then of course construction packages. So that was good feedback. I joined the Deployment Specialist Committee, and from there I submitted a proposal to form an engineering best practices working group, and that's been accepted. So now we have about a 13-member working group looking at engineering best practices. And this is to combat the issue, comparisons sometimes are helpful. Like if you think of the DOTs, right? So Department of Transportation has very well-defined, very specific standards, guidelines, specifications on how things need to be done. I would even say the utility industry is better than the telecom industry. In the telecom industry, it is so all over the place. I mean, every company will say, yes, we have a standard, it's ours, and nobody can use it. So it's kind of self-defeating. Anyways, the committee and the leadership at Fiber Broadband agreed this was a good initiative. And what's happened since we formed this working group is now we're looking at creating this engineering standards committee, which could be very big and all-encompassing. It could be a game changer for the industry, I think. But we're going to take it in bite-sized chunks. So we're going to start with things like, drawing standards and data models and basic workflows, right? So that everybody can start to kind of leverage some common standards and common processes. And the whole goal is to accelerate broadband deployment. So that's the overarching goal here. So I think we're really happy about this update. And then use cases and customer value. So when you think about design, engineering, construction companies, a lot of this comes down to productivity, profitability, scale of the business, ability to win more business. And so with that, we're trying to help them capture design standards and regulations to really reduce errors and rework. We consistently heard that doing things over and over again or fixing problems is an absolute headache. It's a bit of a nightmare in some cases. The other piece is to automate repetitive tasks. So another example I can use is there's some software companies out there that do what I would call like a high-level design. So you can automate, this layout of a network, but you don't know which side of the street it's on necessarily. You don't know how it's going to cross the road. You don't know which poles, it's going to use necessarily. I would call it like a good budgetary guideline. But what we're trying to do is automate very specific tasks and workflows to create a shorter cycle time and greater productivity in low-level design, detailed design. And then finally building in network models and validation checks and rules, to really minimize the QA/QC. So that was the other thing we heard, which was resoundingly unanimous across all the companies we talked to, which was they were spending way too much time on QA/QC. And we think we can really help with that by kind of capturing or institutionalizing, the design standards and best practices in the platform. So CSPs and ISPs, same as above, right? They want to do those exact same things with some differences. To them, driving consistency and quality for both staff and contractors is key. I would estimate that in the telecom space, the major providers, the tier 1, tier 2 companies, the big guys, they probably outsource 80 to 90% of their design and engineering and almost 100% of their construction. And so it's important for them to have tools that work across that partner base, right? That contractor base. Also leveraging common tools and workflows for both, well, actually all three, like design, permit, construction. What's happening today is they're using different tools and processes in each of those steps, and it's really inefficient. And then overall, it's accelerating time to market. With the BEAD programs being approved, and I know that's a US thing, but it's really going to be a game changer. So at a state level now, there's 20-something states that have approved their projects. The goals are well established, the key players are engaged, and we are about to see a ton of fiber to the home deployment and broadband deployment in the United States. Final piece here, utility communications, fiber networks. And so utilities are continuously looking at ways that they can improve their communications to support grid operations. And that's actually changing. It's not about just protection and control anymore. There's a lot of very smart sensors. There's even the ability for fibers to kind of be self-aware and detect movement and temperature, which is amazing. Just when you thought, how far can this evolve? Well, fibers themselves can become sensors. So it's pretty interesting what's going on. But what we're trying to focus on is integrated design, leveraging the utility infrastructure and overhead and underground engineering standards for fiber and generally communications deployment. And so we can really help out quite a bit in that area. So I wanted to let you know that you can speak with us. So Sarah Jones is here, Jim Lucas is here. I'm here to answer questions. We would be happy if any of you, want to learn more about this. And I would encourage you to pay close attention to Sangeetha's presentation at 1 o'clock. It's going to be really fantastic. So anyway, thank you. Quick update from me. Appreciate your time and attention.